Thank you for having me here. It's a really wonderful place. I can do this every year. So. A little bit about myself, just to introduce myself and to set the stage. I'm working for eProceed. We're headquartered in Luxembourg. Myself, I'm stationed in the Dutch office in the Netherlands. We have offices all over Europe, unfortunately not in Spain or Malaga. And my Spanish is really bad. I get totally confused by French, what they speak in Luxembourg, and Portuguese, what they do in Porto. So I'll try and do it in English here today. We do three types of things. We have services for hosting and managed services and Azure services for our customers. And from that perspective, serverless is of course interesting because then the customers don't need that anymore, and it can be of interest to offer something like that for your customers. But we also do consultancy services, and that's where my background lies as a developer and architect. And we do projects, end-to-end projects and reviews and trainings. And we have a product, FSIP. Currently, I'm head of the Center of Excellence, so basically what I do is within eProceed make sure that we have good ways of working in terms of how we develop software, what we do in terms of continuous integration, how we do unit testing, and all those things for the different technologies that we're using. And in today's world, that's a lot of different technologies. I started out back in the days, I'm not going to tell you when because then you'll know how old I am, but with Java. And at that point, we also had, there was some JavaScript around, but not really serious JavaScript. It was more for the browser, of course. And over the years, all these new technologies and new deployments have appeared, and that has a big impact on you as a developer, how you can test your code, how you're supposed to be deploying it, and how you can make sure that you develop good quality. I still like Java the best. I'm doing a lot of Node projects at the moment, and I've been doing a lot of integration projects as well. Since I started with Java, I really like that, so I was really happy when this new framework was announced. FN, a framework really focused on Java developers to do serverless development, which sounds very counterintuitive. One of the first things they came up with Java was, of course, an enterprise edition with big application servers and all that stuff around it. How many of you have been working with a serverless Java framework? Let's see one hand there, a couple of hands. Okay, good. And does anybody have any experience with Lambda or other non-Java serverless frameworks? A little bit more. Okay, so what I'll do is I'll introduce it and show a demo at the end, if the demo gods are with me. Just before we started, there was like a short circuit of the power, so I'm not connected to the power anymore, but now I'm connected to the internet still, so the demo should work. And so the agenda for today is just a little bit of setting the stage for serverless and the different architectures and what it means for your code. And then I'll deep dive into FN and the components that it consists of. I'll show you how to create a serverless function and how to call that function and then do a demo so that you can see for yourself what it looks like in code. It's not a how should I say that? If you already know everything about FN, it might be a bit boring and you might want to run out and go to the next door or something like that, because it's not a really expert explanation of FN, the framework. It's introducing this concept for Java developers. So first, for serverless, there's a couple of conflicting, or maybe not conflicting, but different types of definitions for serverless. And the first one I know myself really well because we did a couple of projects with them is, of course, this notion of having a backend as a service, for example, for your mobile backends. And the applications use an ecosystem in the cloud to access databases, for example. And so one of the examples that I've been working with for the last year is the Oracle Mobile Cloud Service, where you basically build a Node application, but it will be run in the mobile cloud service. You don't do any of the infrastructure, you just access the database that's there. And so basically, for the consumer of this Node function, it's going to be a proper managed service, but you as a developer don't see any of the infrastructure that's behind it. Now, a more modern definition of that is, of course, function as a service, and that flows more with the picture that you can see. In the past, of course, everybody must have done those. We made monolith applications. So, for example, if I'm building a web shop, I will have a Java EE application with session beans and entity beans and servlets. Maybe you skip the beans, but you still have your servlets. So you will have a monolithic application that will take care of the entire web shop. And in modern days, we see more and more microservices where we want to have smaller components and containerize them, and don't have all the hassle of configuration and doing the correct changes in your application. If you change something in the order bean, then all the other beans give you issues and you have a lot of downtime. So that's where the microservices came. And now we see even smaller parts, which are functions. So basically, when you talk about functions as a service, that's serverless. But something like a mobile backend or a backend as a service is also serverless. My talk today is about the functions as a service, not about the other one. One of the features, of course, of functions we will discuss in a bit. Now, if you look at your application that you're going to build, and you do it from a traditional Java Enterprise Edition perspective, then you would build your web shop in whatever language you like, maybe JavaScript nowadays, not Java. Build your store in your, and deploy it on your application server and have some database behind it, an enterprise database probably already existing for many, many years. If you're lucky, you can build a new one. And all the data is in that one database, and they are all pointing to each other, right? So if you do an order, that order object will point to the customer table that is in that table. So it's one big application that belongs together, and you don't really reuse any of those components for other purposes. Now, if you go to a microservice, then you basically split up the monolith in different components and build containers around that and create your microservices. So in this case, you could have an order microservice and a product microservice. It's still very much similar in terms of layers compared to your monolith. The advantages, of course, in a microservice is that you could have different technologies for different microservices. So if you happen to be building something in Node in the product microservice, you can do it in Java in the other one, and that doesn't matter at all because they're all self-contained. They are all in their own container, whereas that of course doesn't work very well for a monolith, where you all deploy to the same application server and all go into the same database. Now, it's not a goal in itself, of course, to have like 10 different types of technologies in your organization, but it is very good to be flexible because some technologies are a better fit for certain problems than others. And so it is nice to be able to pick and choose the most valid technical option for your specific problem. If you look at serverless, it's even smaller because there what you will see, and those are sitting behind the API gateway, are really functions. So basically it's more about your Java class exposing that as a function and anybody can use it, right? So that's a really small unit that you reuse and can call from anywhere. In serverless architectures, you can often see that you will have a web shop that, for example, will access a certain database directly and use a function if it has some more complicated information that is needed. Now, of course, you don't have to do this. You can still have your monolith and use a function to do a specific function that you need, for example, get a holiday or something like that, right? So maybe you want to order and you don't deliver on holidays. You could call a function that is living somewhere, a very small Java function that gives you the functionality. If you put a date in, it will tell you whether it's a holiday or not. If you're delivering to the Netherlands, we have different holidays than, for example, in the UK. Then you can even check per country. And so those are use cases where it's not necessary to completely get rid of your current architecture, but use the flexibilities of those functions to do small tasks that they're really good at. So it's a very specialized thing, a function. And you would expose it not as a library, so you don't have to download it and put a Maven dependency in your Java code, but you would actually call it remotely somewhere in a cloud. And that cloud would take care of the load balancing and scaling of that function for you. So if it's Christmas, of course everybody will do a lot of ordering, then that will scale automatically. That puts some restrictions on your function, of course. So you cannot just write any Java code. It should be stateless and it should be possible to scale. But those are the differences for your different architectures. And as I said, it's a very common scenario to use a function for something specific and not for your entire application. It's not, you don't have to build everything that way. Now you can of course also have events. This one I got from ThoughtWorks website. It's a really insightful website to, to read about serverless functions. And one of the things that you can see is one of the functions you could have could be a click processor. So rather than having one consumer that will do something with events that are coming in, you would have multiple, and they all do their job depending on how often events are fired. So if you summarize that with this example, you can see that serverless is basically that you run your code without managing or provisioning your own servers. And that is a very important concept, right? If I build a Java application in JEE, I have to and run it. I have to manage my own servers. I know where it's deployed. With serverless, you don't provision your own servers. If you need more, it will automatically scale. You don't code against a framework or library, you call them, right? So you call the function, is this a business holiday? You're not calling the API that is in the Java code. And it's like regular coding, and I'm going to show that in an example where you can do a regular Java project in NetBeans, building your Java function, and so not needing any background information about FN, apart from a couple of maybe entry points and exit points. And so you can use everything you already know and love about Java. And you can do unit testing, and you can do your Java coding just the way you're used to it. And normally when you deploy, you upload or a zip or a jar, and then some proprietary API will initiate that update. And very important, functions themselves are stateless. Now, of course, other architectures also scale. It's not new to scale. That is, of course, something that we've always wanted to do, and we want to scale databases, and we want to scale whatever application we have. Now, if you look at Java Enterprise Edition and how that scales, and basically what you see is that you can scale per layer, right? So if the database is really busy, you will put a cluster, or maybe you put multiple nodes in that cluster. If it's the application server that needs to be scaled, then you will put those in a cluster. And so you don't really scale a function, something that is being used a lot, but you scale an entire layer. And then you can of course do very complicated stuff about deploying different types of loads to different types of application servers and manage and tune those, but you have to think about how can I deploy my code in such a way that it will scale the way I want, and that's quite cumbersome when you have a J2E application, JE, sorry. Now microservices are a little bit more flexible, and there you scale per container, so per microservice. So if your ordering service microservice is really busy, you can scale that and put multiple instances of that. If your search product microservice is busy, you will do it like that. But that has a bigger unit of work compared to functions, because they scale per invocation of a specific function. And that of course also gives you the opportunity to, when you go to a cloud provider, to pay per invocation of the function. So you can actually make sure that if you don't use something, you don't pay, not for the entire microservice or for the entire CPU or for the number of messages coming in, but very specific for the invocation of a specific function. It can be scaled and you can pay, or whatever type of model you're going to do. Now, of course, with JEE and microservices, they can be either stateless or stateful. A function is stateless. And so it will need, as you can see in the picture that I showed you, and I will show that for FN as well, you need some outside possibility to store state. There are, of course, functions that you can come up with that don't need any state. For example, if you want to generate a barcode, a QR code, or something like that, then you don't need to store state. You can just get some input in and you can output your barcode. But there's, of course, a lot of other examples of functions where you do want to store state. Say that I have an ordering function, then of course I want to store that state somewhere so that I can see that it happened. And so you need to think about how do I do that in my function, because the function itself cannot do that, because it should be scalable, and that's why you need some external storage for that. And they're usually short-lived. In Lambda you have a max of 5 minutes, so you cannot run it for longer than 5 minutes. If you look at, for example, back to the other one, the mobile cloud services, they also often have a timeout of, for example, 15 or 20 minutes, so that you don't eat too much resources. I think that's from an operations manager for the cloud provider. It's not really an architectural limit, although it's not really nice to have things open for longer than 5 minutes. It's better to use events if you need that. And you can do no caching. So every invocation will be a new JVM that spins up, so there's no caching. Every time you do the same query, it will run that again. Right, so that is a very big difference compared to how you do your JEE architecture. So why would we want to do that? Well, there's one big advantage is, of course, is that you don't have to do any system administration. You don't know what the operating system is that is running on. You have no clue about any of the infrastructure components. You just upload your function. So you don't have any system administration. The horizontally scaling is, of course, really nice. And it reduces the operational cost. You don't have to buy a server or get a compute node in Amazon or in Azure or the Oracle Cloud. You only have to pay for the single invocations that you do of that function. Everybody else is sharing your resources, so they can offer that for a much cheaper price. Because you can reuse those functions, it saves you development costs, right? So there's a couple of things, like the holidays I was just mentioning. I'm sure everybody has to do that once in their career, that you need to plan something for the next business day, and that you need to know when is the holiday, so I need to know when is this business day there. So those types of things that you build over and over again, generating the QR code, similar thing, right? It saves you a lot of time if you can reuse those in your organization without having all these complicated things about loading the libraries or having all these interfaces that you don't need, that you have in a microservice. Well, and then of course you can build something really fast. However, there's also a number of downsides to this, of course. First of all, a lot of it has a lot of vendor control, right? If I'm deploying something to Lambda, or if I'm doing something in Azure, and Microsoft decides to update or upgrade or patch or do whatever, there's nothing I can do, so my function is not available. And this is true for a lot of these hosted environments, of course. But for your function, if you're using it in a lot of applications, it's really painful, of course. You'll end up with a vendor lock-in. Most of the frameworks are very specific, so Lambda functions are specific compared to what Azure is offering. And a lot of the tooling is not that mature. And of course, the operations are going to be harder, because if something goes wrong, it's hard to see what you do. And one other thing that could be a topic of an entire different presentation is, of course, that you will have repetition of logic in your client. Because you can imagine if you have 10 different functions, that normally you would put that in a microservice or in a service and offer that as, one order process where you do several different steps, one after the other. Now you will build that in your web shop, so more logic will go into your client. And that means that you have a lot of repetition of that logic in your client. And it's a bit hard to do integration testing because your functions are in production, right? So if I want to integrate that with, I don't want to really order something, then you should come up with some solution for that. Either have multiple environments or something like that. Now, under the covers, if you look at a Java function, of course it's a Java function, so it still needs servers. So it's called serverless, but it has servers, of course. It's just not something that you need to worry about, but still I like to know it, so that's why I put this picture here. When you build your web shop and you call a Java function, Amazon has an API gateway, and that will do the dynamic API calls over HTTP to whatever serverless function that you have running. So if you created the holidays function in Lambda, the API gateway will know where it is based on the path, and you can call it from your web shop. And so you can do a whole set of calls from your web shop, and there we have that repetition of logic if you're not careful, and call these functions. Now within Lambda, because they're all stateless, but you do want to store some state, right? There's a couple of options to do something with state, and so you have access to the Dynamo database. There's streams, so Kinesis is used for the streaming, and there's object storage. So you can, if you want to store something, store it there, and then the function can look for it, for example, to do it. The function itself will not have state, as I said. It's not like a long-running process where you can go 3 times and ask for something, because every time you call it, you'll get the response back right away. But what you could do, of course, is call it from your function, call something in the database, and serve it back to the client. Another feature that they have in Lambda that I didn't see yet, but I need to look for it in the FN, which is what I'm going to talk about next, is that you can schedule those calls. So you can also create a function and say, I want this to run every day. I want to run it every hour whenever the presentation, the next one starts. I want to run a function that will send an alert to everybody saying, hey, the next presentation starts, or something like that. So you don't have to actively call it, you can also schedule it. And so you see a number of components, but they're all in Amazon Web Services and AWS. So there's nothing you can do about it to change it. And the way that you upload it to your AWS Lambda is specific for AWS. So in comes FN. Now here we have an open source solution, and it has support for multiple languages. So you can do stuff in JavaScript and in Go and in Java, Python. There's lots of support. But one of the key things was that that is geared towards Java developers. And it's open source, so you don't have the vendor lock-in, and anybody can offer this framework as a service, and I'll show you it on my VirtualBox in a bit. And that is of course attractive, plus it has a functions development kit for Java as well. Now if you look at the framework, it consists of a couple of components that you can swap. But by default, if you just install the default, it will give you this, a MySQL server for the database, Redis for the message queue, then the FN server itself, which includes the API gateway. Then there's a user interface that I will show you, so you can actually monitor what's happening, what functions are deployed, how often is it called, and some logging and statistics, so you can do some analysis on it. Which is of course important if you would decide to open up FN and provide it to your developers. Because if you look at FN, it basically has 2 components, right? One is, I have this environment, this serverless environment that I'm going to offer to all the developers, who then deploy into my environment and everybody can call it. So for example, if you're working for a bank, you could host your own serverless framework with these components, swap out some that you don't like. If you don't like MySQL and you prefer Postgres, you can swap it out. And then you can host as an organization this serverless framework, put it in some cloud, that's another option of course, and then your developers can create functions and deploy to it, and other developers that are building other applications can call those functions, and that is all within this framework then where it's being used. So it's open source and there's no vendor lock-in at all, because you can run it wherever you want. It's all open source code. Now, if you look at the picture again, that is very similar to what you saw from Lambda. The framework is also built by some people that did I/O functions before, so they knew what they were doing. So it's very new, but it has all the well-known concepts that you would expect from a framework like this. And now, if I build my web shop, I should put some load balancer in front to make sure that that I can call the APIs. And then the FN server contains all the routes. So say I have a function that says holidays, the FN server will know, and the FN server has the functions running inside. There, as I said, the database you can swap out. Messages, there's also support for multiple. If you miss one, then of course it's open source, so you can add support for another one. And then it uses Docker to register all your containers, and there's an object store for for it as well. There's one thing, this is all open source, it's written in Go, so it's a lot of very well-known Java concepts that you see here, but the framework itself is written in Go, so if you want to help with that, I guess you should learn Go. I'm going to show you how you can start the server and how you can look at the UI and do all that stuff, but from a developer perspective, of course, you wouldn't do that. And my demo for the developers is a bit more boring because there's really not much to it, because it's just Java, right? So I can build different, very complicated or simple Java functions. I'm sure you guys can think of a lot more interesting concepts than me, because that's the whole idea, right? You write these functions and you don't care what is behind. But then I guess most people still want to take a peek, so I'm going to show you anyway. Now what happens if you deploy? Normally when you, we all know and love or hate Maven, of course. When you build something, when you build your code, it will create a jar file or a WAR file or whatever. Put it somewhere in the repository, and then you can deploy it to whatever application server that you want. Now for FN, we do something similar. And there's one thing that made me a bit dizzy in the beginning, and that is the FN server currently, if you don't have to, but the default way of running the FN framework is in a Docker container. And every single function that you create is also its own Docker container. So basically you're running Docker in Docker. Now if you try this, it's really hard. It doesn't really is that well supported on Windows, so it's easiest to do that in Linux or on your Mac. So I have a virtual box or some compute node in cloud. But basically what happens when you build your function, it will build a container, a Docker container. And it will automatically bump the version, so it will know, oh, it's the next version, so it gets a new version number. And then that will be pushed to the Docker registry. If you don't want to push it in a Docker registry, you can push it in your own registry, so you can connect it to other registries. And the last step is then to update the route. And I'm going to show you in a bit what it looks like, but at first I had my function 001, and now if I call hello, hello world or whatever, I want to go to 002. Right, so it will update the route, how to get there, and it will download the image from the Docker registry. So as I said before, what can be a little bit confusing is the FN server itself is running in Docker, and then your function is a Docker container running in Docker. So it is, from an administrator perspective, a lot of Docker. So if you want to do this, it helps if you know a little bit about that. As a developer, you don't have much to do with that, right? Because you just call fn deploy and you don't care what is happening behind the scenes. And you could automate that with a build tool, and so you would just keep building. And you can see there that you can call them based on a URL once they're deployed there. So I'll first go over the steps and then I'll show them on my laptop to see how you can do that. But the easiest way to do this, to make sure that it deploys and everything is conforming to the standards and what the framework expects, is to use the FDK, the Function Development Kit. This is for Java. You can also use Go or JavaScript or something else. So the first thing you will do is you initialize a function using fn init. You can do that if you have downloaded the fn client. So to do this, you need to download the fn client. Then of course you write the Java code, and you can run it locally on your machine using the fn client, and you can also test your code. So fn has a number of commands, init, build, test, run, so that you can make sure that it works according to your expectations, and then you can deploy it. To do that, you have to define an app. You can deploy multiple functions into one app. To me, that's a bit strange. You know, I just was telling you about the difference between microservices and functions, and then I can bundle multiple functions in one app. Well, I guess it's useful, but it's sort of defeats the purpose maybe. But that's, I think, a debate that you can have. Do I put one function in one app, or do I do a whole bunch of functions within each app? And then you deploy it, as I showed you in the previous one, and you call your function. And then, of course, if you do test-driven development, you could first test it, and then build it, and then test it again. The function development kit is a Java library. It's an API. I will show you in NetBeans. It's downloaded with a Maven dependency. It uses a runtime Docker image to run in. As I said, it's running Docker in Docker. So the FN server is a Docker. And then it needs the function itself to be a Docker as well. It has a JUnit rule and a built-in Docker to have the repeatable builds. So I'm going to show you this one in a bit, so you can start one. I'll just start with the hello. I'm not going to show you complicated code because you guys know that as well as me how to do that. And then you call build, run, then you do your test. You can do fn test, but you can also run your test within your IDE. I'll show you that in a bit. Then you deploy it. If you do local, it won't be published to the Docker registry. So if you just want to test it, you don't want to publish it to whatever registry that you're running, either your private or the Docker registry, you use local. So you can test your own functions without publishing it to anywhere else. And then you can call it. Basically, it exposes by default everything as HTTP request, as REST. So you call it either using curl or a browser, or with a FN call. All right. Now enough talking. I'll show you some stuff in action. The first thing that I will do is start Docker. So to start the Docker container, that's the FN server. So now I'm going to start my cloud serverless environment for the developers to work with. Right? So this will host the functions. So first I'll start the server. Okay. Now I will start the event server. And you can see now it's listening to 8080. So you can see the port that's listening to, and so now I have started my my event server, and it's listening for requests. There's also, as I said, a user interface, which I run with a long Docker commit. There you go. So this will start on port 4000. We'll start the user interface, and there you can see what functions are deployed. So we'll do that. I'll show you which ones are deployed, and we'll create a new one. It's listening on 4000, so I'll go to the browser, start a new one. I have a lot of tabs open. So I'm running the FN server right now on VirtualBox in the CentOS. Yeah, the resolution on this screen is not that nice. Let me see. So currently I don't have any apps. Now we're gonna create one. So as I said, what I will do with the FDK is you get some boilerplate code. It needs Docker and all that stuff for that, so I create that here and then I push it to Git and I pull it again at my Windows machine so I can use my own NetBeans thingy. That's a little bit of a strange workaround because the client installation of the FDK is not done yet for Windows. They have like a to-do on there. So if anybody likes to do that type of thing, I would be very grateful. So here I need to tell it the, let me go to the general page. I go to FM demos, that's my GitHub. So I have some stuff there. I'll create a hello demo. So I'll do this init. It's Java. Demo. So it's now creating, and it's created 4 files in this directory. The function YAML upon that we all know, and some source code. I'll push that real quick. Alright, so now I have my boilerplate code, and I'll show you what it looks like. I'll pull it. I'll go to NetBeans and we open project. This is my demo. Okay, so here you can see I have some Java code. Now, instead of hello, I'll say bye because I'm out of time. Now if I run my code, it will fail. So it didn't run, right? So I'll change my code. Done. And I can push this. Okay. I'll get the changes and build it here. I'll do for both so you can see what happens. So you can see here that it built it. So now I can say test. I didn't define a test here, so if you define input and output, but I don't have the time for that, you can define JSON tests with input and output, and that will give you a way to test it from the outside. And I can of course deploy, and then it will build a container. Oh, yeah. Deploy demo. local. So it built it, and now let's go to the user interface. See that we have it. No, there's not much to see here, right? Oh, I guess I'm running out of time. Oh, here's my hello demo. So you can run it from here. You can also put input here and test it, and it will show up here in the console. And so basically, what you saw to wrap up is that I wrote regular Java in my NetBeans, and all you need to do is deploy it into your server, and then you have the functions in here, and then you can start calling it from the outside using regular HTTP REST requests. So I guess I'll take questions now.